Good evening, class. We're going to skip ahead now because we're not going to have our test until next Tuesday. And we're going to go ahead and start on Chapter 3. So tonight we're going to talk about Lesson 3.1, which is on rounding and estimating. Some of this is going to be review, but some of it's going to be new. So really pay attention and make sure that you're ready for what we're going to do in class today. Now we're going to talk about 3 methods of estimating. The first one is going to be rounding. You've seen rounding before. And so let me back up just a little bit here. Okay, you've seen rounding before. All right. And so in rounding, the rule, as you probably remember from years past, is that if we're rounding a place, we look to the next digit, the one that comes to its right, and if that digit is 5 or above, we give the digit that we're rounding a shove. In other words, move it up. Whereas if it's 4 or below, we let it go. So let's go ahead and let's actually practice rounding some numbers. So I'm going to give you one number. Let's take an example like 5.28349, otherwise known as 5 and 28,349 hundred thousandths. And we're going to round this number to 4 different places. Let's round it to the nearest whole number. Let's round it to the nearest hundredth, to the nearest tenth, and also to the nearest 10 thousandths. And let's color code these so that our work doesn't get too messy. Okay? All right. So, and actually, since rounding is something that you've done before, why don't you go ahead and pause the video and write this number down on a piece of paper or on your daily quiz log and round it right now to the nearest whole number, to the nearest hundredth, to the nearest tenth, and to the nearest 10 thousandths. And make sure each time that you always go back and always go back to the original number. Don't pick one of your answers that you've already done. Always start with the original number and round it. Okay? So pause the video now and come back once you've rounded to these 4 places. All right. If you follow directions, first you rounded to the nearest whole number. So you came up here and 5 is in the whole number case, a whole number place. So you look to the right, and to the right is a 2. And 2 is going to fit the 4 below, let it go. So I just write down 5. Everything from the decimal point on gets chopped off. Notice I don't even put the decimal point down. My answer is 5. Okay. Now let's round to the nearest hundredths place. The hundredths place is the one that's occupied by the 8. So again, we always look to the right. Okay, so we look to the right of the 8. We see a 3. And again, it's 4 or below. So let's let it go. And so I get 5.28. Okay, and the rest of the number chops off. I do not continue. If I add extra zeros here, when I'm rounding, it kind of implies that the next couple digits are zeros. And we know that they're not. They were actually digits like 3, 4, and 9. So it is not accurate to record extra decimals when you're rounding decimals. Chop off right at the place they ask you to round to. Okay, that's kind of a fine point. We'll talk about it a little bit more in class. All right, now let's round to the nearest tenth. All right, so we got to actually back up. The tenth was the 2, right? So now we look from the 2, we look at the 8. Now, in this case, we hit the 5 or above, give it a shove. So we're rounding to the nearest tenth, so 5 point, the 2 is going to go up 1 to 3. When we're rounding, we never go down. We either chop off extra stuff or we increase a digit, at least with positive numbers. Okay, and so the correct answer when we round to the nearest tenth is 5.3. All right, that leaves one more, the nearest 10 thousandths. Now, the 10 thousandths isn't even easy to find, so let's count over. The tenths, tenths, hundredths, thousandths, 10 thousandths. So we're talking about the 4 here. All right, so we look to the right. 9 is definitely above 5, so we're going to give it a shove, so that 4 is going to turn into a 5. So we're going to round to 5.283. Notice none of those digits changed, but the 4, the one in the 10 thousandths place, because of the 9, is going to go up to a 5. All right? And now we have successfully rounded the exact same number to 4 different decimal places. All right? And so that should be a nice review of rounding. All right. Now, rounding is really handy because rounding you can use pretty much anytime. You can do all kinds of calculations, addition, subtraction, multiplication, division. We can round our final answers. Sometimes we round numbers before we do calculations. And so rounding is probably the most all-purpose estimation technique. But we've got some other ones that are kind of specialized. And so in certain situations, they're actually really handy. All right, so let's go ahead and let's continue. Let's move on. Let's talk about front-end estimation. Now, I'm going to admit front-end estimation is not most people's favorite estimation technique. It takes a little bit more work, but it has a really good advantage, and that is that front-end estimation is very accurate. You put more work in on the front end, but you get a very, very accurate answer. All right, so let's take a look at what we do on this. So with front-end estimation, the reason it's called front-end estimation is what we're going to do is we're going to divide the number. Or the numbers that we're adding. First of all, this is only used for adding up a bunch of numbers. And what we're going to do is we're going to kind of divide the numbers. So if I took some numbers like 2.71, 1.73, and 1.10, I'm going to decide what I'm going to consider to be the front of the number. Now, I'm going to consider the front of the number to be the whole numbers, the ones in front of the decimal. Okay, and here's what we do. For the numbers in the first part, we just add normally. So we're just going to add 2 plus 1 plus 1, which is exactly equal to 4. All right? No big deal there, no rounding, no anything. Then for the rest of the number, I'm going to round them. I'm going to use a wavy equals to show that I rounded it. I'm going to round these to the nearest tenth. And so 0.71 is going to round to 0.7. 0.73 will also round to 0.7, and 0.10 is already 0.1. And if I add these up, I get 1.5. All right? So I want you to notice the front end I added exactly the way it was. And the back end, I rounded first to the nearest tenth, and then I added them up. Now I put those two pieces together, and I get 5.5. That's going to be my estimate. Now, that was, whoops, yep, that's correct. Now, that was a little bit more work, assuredly. And actually, in this case, the numbers that I picked would have been pretty easy to just add. But what if there were 8 or 9 numbers, and what if the numbers were a lot tougher? The benefit is that with front-end estimation, we're usually only off by a couple of cents. In fact, in this case, if I actually added this up on a calculator, or if I added it up carefully by hand, it would come out to be $5.54. So I'm off by exactly 4 pennies. Not too bad. Okay, and again, these numbers are pretty easy, but you're going to see examples in the textbook when we do practice problems in class that will be a little trickier. And if we're looking for a very accurate estimate, then front-end estimation is the technique you want to pick, especially if you're adding up a bunch of decimals. Okay, if you're doing something more complicated like subtracting or multiplying or dividing, then this is not the method for you, and we're going to need to move on to another method. Either go back to rounding or wait till tomorrow's lesson where we're going to talk about some other cool methods. Now, I said we're going to talk about 3. So we've done rounding and we've done front-end estimation. So the next and the third one is called clustering. Now this is also only used for adding. And it's even worse than that. You can only use it for adding, and you can only use it when you're adding up a bunch of numbers that are reasonably close to the same number. So look at this example I've already written out. 4.50, and I'm sorry these are a little hard to read, plus 5.20 plus 5.55. Alright, they're not super close, but they're all pretty close to what easy number? Alright, if I want to go really easy, I'd say they're all pretty close to 5. 4.5 is a little less, 5.5 is a little more, 5.2 is pretty close. So here's how clustering works. What you do is you take all the numbers and you say, all right, these are all pretty close to 5. All right, pick a number that they kind of average to, at least in your mind. Now, how many did I have? I have 3, and I'm adding them up. So instead of repeated addition, 5, something close to 5 plus something close to 5 plus something close to 5, that is actually the definition of multiplication. So since there's 3 of them, and they're all about 5, 3 times 5 is 15. That is literally all there is to clustering. Okay? Well, all right, then why don't you try one on your own? Suppose I give you a little bit harder example, 26.7 plus 26.2 plus 24.52 plus 25.25. Go ahead and pause the video and use clustering and come up with an approximate sum. And you don't have to spend a lot of time on this. You can pick the obvious number to cluster to, and I think you'll be able to get an answer very quickly. All right, I'll see you in just a few seconds. All right, so you looked at these 4 numbers, and what did you decide to cluster them to? Well, all right, well, 2 of them are a little bit over 25, one of them's a little under 25, one is very close to 25. So how about we just say they're all pretty close to 25, and there are 4 of them. And 4 times 25, as we know, 4 quarters is worth $1, and so that was really easy. 4 times 25 is 100, and that's actually not a bad estimate. Now, that said, if I wanted to be more accurate, could I go ahead and do front-end estimation on these? I could. I could round them to the nearest whole number and add them up. I could do that too. Okay, so there's not just one method that works, but for ones that lend itself to clustering, I think clustering is the easiest method for estimating. Again, you can't use it very often, but when you can, I would definitely use it. Okay, if you want, all right, let's do a quick review here. Okay, so method number one is one you've seen forever. It's just plain old rounding. It is not too hard. It does save you some work, and you've been doing it forever. It's also very versatile. You can use it with just about any kind of problem, or you can use it at the very end of a problem to just round an answer to a nearest digit, whatever you want it to be. The other one that we did is front-end estimation. Okay, and again, the benefits are that it is very accurate. The downside is it takes a little longer. And then the final method, which is by far my favorite estimation technique, is called clustering. And that is, I just think it's really cool. Now we're going to also talk about another easy one, but it's one that we're going to primarily use with multiplication division. So we'll hold off on that till the next lesson. Okay? So be ready to go over all this in class tomorrow. And without further ado, I've got one corny little slide. So remember, all right, let's see here. Let me see. See if you can figure out what this is. Oops, can't spell today. All right, so that's what I'm going to leave you with today. See if you can figure that out. I'll see you in class tomorrow.